Okay, today we're going to derive arcsin x, which is sine to the -1 of x. Well, the first thing that we're going to do is we're going to let it equal y. We're going to let it equal y. And then we're going to look at the inverse relationship of arcsin x equals y. Now, the inverse relationship states that it is the same as sine y equals x. Well, that we can work with. Because we can use implicit differentiation to derive both sides of it separately, get dy over dx on one side, and then derive the inverse formula. Well, let's start with dy dx of sine y equals dy dx of x. Well, here we're deriving sine y with respect to x, so there's going to be a chain rule here, right? There's going to be a chain rule here. Chain rule. And here we're just deriving x with respect to x. X has the exponent 1, so x is actually just going to become 1. So let's start with the chain. Let's start with the chain rule here. Now, I like to do it with f of x and g of x. So let's write it up here. F composed with g of x, in this case, is going to be sine x composed with y, which means that f of x is the outer function. F of x is the outer function, sine x, and g of x is the inner function, y. Well, the derivative of the outer function is cosine x, and the derivative of the inner function is dy over dx. Because we're still just deriving y with respect to x. This is, however, what we're solving for, because this is the slope of the tangent line. Slope of tangent line. Okay, so the next thing that we're going to do, actually, let me write down the chain rule really quickly since we have all this work up here. Let me just write it down. Since we're doing f and g of x, let's write down that f composed with g of x prime is going to be f prime of g of x times g prime of x. Well, okay. Now we can just pretty much plug things in because we've done all the work over here, haven't we? We can just plug in our sine x and our y, and we're going to end up with cosine, because the derivative of f of x is cosine, but instead of x, it's going to be y. And we're going to multiply that by g prime of x, which is dy over dx. dy over dx. And on the right side, we just have 1. Well, now we're just going to divide by cosine y, because then we have dy over dx on one side. So we're going to get dy over dx, which is our derivative, is 1 over cosine y. Well, now what? Because we still have a y in the denominator, and we really don't want to have a y in the denominator. So now we remember that sine y is x, which is x over 1. And sine y is also opposite over hypotenuse. So we're going to draw a triangle. We're going to draw a triangle right here. And we're going to give it an angle y. And we're going to say, okay, we know that the opposite of this angle is x. And we know that the hypotenuse is 1. So we need to find this length right here. Well, this length right here is going to be 1 squared minus x squared, which is just 1 minus x, because 1 squared is just 1. So now we have a triangle, and we can use this triangle, and the length we just got, we can use that. We can go, well, what is cosine y? Cosine y is adjacent over hypotenuse. Well, we just figured out what adjacent was. This is adjacent, right? This is adjacent. And so we know that cosine y equals square root of 1 minus x squared over 1 over 1. Well, okay, let's just plug that in because our dy over dx just becomes 1 over square root of 1 minus x squared. And that's all it is. And if you're wondering how I got this length, I'm just going to make a note. I mean, if you're in Calculus 1, you probably do remember the Pythagorean theorem, but it can never hurt to show your work, right? So a squared plus b squared equals c squared. And here in this case, the hypotenuse is 1, so we know that x squared plus something we didn't know, squared, equals 1 squared. And all I did was subtract x squared so that I could isolate what we didn't know, and we ended up with 1 squared minus x squared. And since they're all squared, we know that what we didn't know was the square root of 1 minus x squared. And that was this length over here. So yes, this right here is our derivative of arcsine. Now maybe you want to actually write that so you remember that at the end you should always go back to your original notation. So this actually equals dy dx of sine to the negative 1